Hi everyone, here's a little problem I'm hoping to help you solve today. You're standing at the top of a cliff that has a stair-step configuration. There's a vertical drop of 7 meters, a 5-meter horizontal shelf, and then another drop of 3 meters to the bottom of the canyon, which is a horizontal floor. You kick a 0.47 kilogram rock, giving it an initial horizontal velocity that barely clears the shelf. What initial horizontal velocity v will be required to barely clear the edge of the shelf below you? We're going to assume the acceleration is 9.81, and we're going to neglect air friction, which will make the problem a little easier. We also have a second part of the problem: how far from the bottom of the second cliff will the projectile land? And these are two very similar questions, so let's go ahead, before we do anything, look at a picture of our scenario. Here we have our person kicking a rock, completely horizontal velocity, and it's following this trajectory where it barely passes this corner of the shelf and lands somewhere X meters away. We don't know exactly, but we know H1 right here, that's going to be our 7 meters tall as our first drop. X1, that's 5 meters across. H2, another 3 meters. So if we're going to define our equations of position, we know y of t is going to be equal to h1 plus h2, or h total, minus g times t squared over 2. There is no velocity component, so that part's 0. That makes this equation a little simpler. And another thing to consider, the x part, because once you kick this rock, the only forces acting on this rock is gravity, and as pulling it downwards, strictly downwards. It does not act in the x directions, because there's no forces in the x direction, the velocity is going to remain constant. Now, this velocity v naught is what we're going to find to figure out how fast it needs to be to go across, and that actually won't be very difficult. But we know our constants. We have h1, x1, h total being h1 plus h2. We know the mass, and we know g. And you can define g negative or positive. Just be careful when you do it. Now, we want to barely clear the shelf below us. So if we're standing at 0 meters to the right and 10 meters up, the shelf's edge is 5 meters to the right and 3 meters above the ground. So when the ball has fallen 7 meters, we know that it must have moved 5 meters to the right. Now, there's a number of ways you can do this. The easiest way, for me at least, is to find the time it takes the ball to fall, or rock to fall 7 meters. So set our y equation. Each 7 meters equal to 1/2 g times t squared. Solve for t. You'll get two values for t, a negative and a positive. Choose the positive one because that fits with our scenario, with, I guess, quote unquote reality, and move forward. Once you have that t, plug that t parameter into x, and it's x, and then set that x value equal to 5 meters. So we have 5 meters times t, the time it takes to fall 7 meters, times v sub naught, or v sub x in this equation. I changed the things accidentally. Solve for v sub x, and we'll get a final answer of 4.2016 meters per second. We're going to keep all the sig figs for now, or all the decimal position for now, and worry about sig figs at the end. But it fell for about 1.2 seconds, and this is its new velocity. Now, going to the next one, how far will this rock travel in the x direction total? So now, instead of finding the time that we need the ball or the rock to fall 7 meters, we're going to find the time that it falls total. So you set y of t. Remember, y of t is equal to h1 plus h2 minus g over g times t squared over 2. And in this case, the way I define g, it should be plus, but I have it on the thing as minus, so we'll just deal with that. Solve that for, set that equal to 0. You're going to get two t's, negative t and a positive t. Choose the positive t because that fits with reality in our situation. Plug that into our x, and you get about 5.999 meters. Now, looking back, if you plug that in, you might get a couple of points off because it's too many sig figs. Here we have 2 sig figs, 0.47, 0.81, 3 sig figs total. So here we want to go to the third sig fig, 1, 2, right here, because we'd already have to round up, it would end up being about 6.00 meters. All right. If you have any questions or comments, please let me know. Good luck.